Hello, everybody. Welcome back. It is 4 o'clock on a Wednesday afternoon, so welcome back. This week, we are going to be covering linear regression. Okay, so let's begin our discussion of linear regression. So, what is linear regression? Well, it is just we are trying to fit a line. Okay, so there is a line. So we're trying to fit a line between all the data points that the features, okay, between the feature and the dependent variable. Okay, so in this case, we have a feature here, right? It is one of the features. And of course, you know that in statistics, we call the feature an independent variable, right? One or more dependent variables. So we're trying to find, and this is the dependent variable. Remember that the dependent variable in machine learning, it goes by many names. You can call it dependent variable. You can call it target variable, okay, response variable. So in machine learning, they call the dependent variable many names, but most of the time it is the dependent variable. So we're trying to fit a line here between this data point that minimizes the errors, okay? That's pretty much it. It's just a line we're trying to draw between the data points that minimizes the errors, okay? So that's what we are trying to do in linear regression. So let's continue. So now, linear regression is a machine learning algorithm. And last week, we covered that there are two kinds of pretty much two major types of machine learning algorithm. We got supervised machine learning algorithm, and we got unsupervised machine learning algorithm. Remember, in supervised machine learning algorithm, we tell the computer what are the features, right? We tell the computer, so these are the features. And then we tell the computer, this is the dependent variable. Okay, that's what we do, right? In supervised learning. In unsupervised learning, this one over here, we do not tell the computer what are the features and what is the dependent variable. We let the computer decide what is the relationship between all the variables. And that's what we call it unsupervised learning because we're not supervising it. So there are two kinds of machine learning algorithms, supervised learning and unsupervised learning. Now, let's focus on unsupervised learning. Let's focus on unsupervised learning. Under supervised learning, we got classification, right? And we got regression. So we got two types of supervised learning. Now, linear regression is a regression, supervised learning. So that's what it is. Linear regression is a supervised learning, okay, regression. And this is linear regression. Now, you're probably wondering, how do we tell if we use a classification or if we use regression? How can we tell when to use classification or regression? Well, that's an excellent question, actually. And that's the one I'm going to answer right now. So this is how you can tell. If the target variable or the response variable or the dependent variable is continuous, then use regression, okay? Now, if the target variable or the response variable or the dependent variable is categorical, okay, or binary, then use classification machine learning algorithm, okay? So it all depends on the type of target variable, response variable, dependent variable. It all depends on this type. Is it continuous? Or is it categorical or binary? If it's continuous, regression. If it's categorical or binary, classification. And that's how you can tell. Now you're probably wondering, what about the features? Whether whether the features are continuous or categorical, does that make a difference? No. The features can be either continuous or it can be categorical or binary, the features. And I'm only talking about the features, okay? So the features can be continuous or categorical, but the target variable, response variable, or dependent variable, if it's continuous, is regression. If it's categorical or binary, then it's classification, okay? Always focus on the response variable, target variable, or dependent variable, okay? It goes by many names. So let's continue. So here's our database, our data set that we're gonna be working on today. And as you can see, it has all of these variables, right? It has all of these variables. And we're gonna be using these variables as our features, okay? We're gonna be using this, the area, the bedrooms, the bathrooms, the stories, and the parking. We're gonna use all these features, okay, to predict the price of houses, okay? The price of houses, okay? So the dependent variable, in this case, or the target variable, response variable, would be the house, the prices of houses, okay? So that's what we're gonna be doing this week, right? What else can you use linear regression? If you think about it, you can make a lot of predictions using linear regression, especially in business. You can predict, what else can you predict? What about if for example, you can predict expenses, right? How you can predict how much revenues you're gonna make based on your marketing campaign, okay? You can make prediction based on that. So linear regression is very powerful and it's actually used a lot in businesses, okay, to make predictions. So let's continue. So now, before you use linear regression, there are certain requirements, okay? And these requirements, we call them assumptions, okay? Assumptions. So think of assumption as requirements, okay? We're talking about requirements, okay? So assumptions are requirements. Think about that. Now, so what are these requirements, okay? Well, let's look at the first one. Let's look at this one. The first requirement is that your features in your dependent variable, they have to have a linear relationship. What is a linear relationship? That means that when your feature goes up, okay, your dependent variable should go up at the same time. You see that? As your x, as your feature goes up, your dependent variable goes up. That's a linear relationship. Or when your feature goes down, then your dependent variable should go down as well. And that's called negative linear relationship. Negative, positive. Okay? Negative or positive. So the relationship has to be linear, okay? If it's not linear, then you cannot use linear regression. That's very important. What's another assumption? Okay, so here's the other assumption. That means that the errors, okay, the errors in your model, okay, they have to be independent from each other. Meaning, let me give you an example. So if you make an error today, the error that you make today should not have an impact on the error that you make tomorrow. Okay, so that's just an example. So it means the error in your model should not be depending on each other. They should not influence each other. So if there's an error in your prediction, should not have an impact on the error on the next prediction. Okay, every error should be independent. Okay, so whatever error you make, whatever the error the model makes, should be independent. They should not be. It should be completely independent. They shouldn't have any influence upon each other. Okay, so that's the other. requirement. What else? Assumption. There's another assumption here. Let's focus on this one. This means that your prediction, okay, the accuracy of your prediction should be the same across the range of data, okay, across the range of observation, whether the observation are small in size or big in size, okay, or big. So across the range of data, your prediction should be pretty much the same, okay? Your prediction should not be more accurate with small values, and it should not be less accurate with big values, or vice versa. The prediction should be the same across the entire data set, okay? So how does that look? It should look like this, okay? So that's perfect prediction, that line there, perfect prediction. So it should be like this, random. You see that? It looks like random. So that's what we're looking for. We're looking for a random, okay? We should not be seeing patterns. You see, there's a pattern here. We should not be seeing that. We see this, there's a pattern here. That is bad. We don't want that. We want this, okay? That's what we want. We want the prediction should be accurate, or whatever, the same prediction should be the same accuracy, whether your data, where your observation is small in value of your observation are large in values. It should be the same, okay? Now, the last one is that your features, okay? Your features should be independent, okay? Should be independent from each other. Remember that in statistics, we call the features independent variables. Okay, there's a reason for that, okay? What that means is that the features, okay, our features do not influence each other, okay? They're not correlated, okay? What do I mean by that, correlated? Well, let me give you an example. Let's say, let me give you an example about that. Let's say education, okay? Education and IQ. So we know education and IQ, this one measures intelligence, right? How intelligent a person is, right? That's what IQ measures. Now, think about this. A person who has a high IQ, most likely, I'm not saying it's going to happen all the time, but most likely a person with high IQ is going to have a higher education, right? And a person who has a low IQ, most likely is going to have low education, right? I'm not saying that's going to happen every single time, but most likely, right? So that means that education and IQ are proxy of each other, right? They're proxy, meaning that they measure the same thing. They're measuring the same thing, okay? So that means they're correlated. That's what it means. You don't want to, if you're building a model, a machine learning model, you don't want features that are proxy of each other. You don't want that, okay? Because then it doesn't add value to your predictive power of your machine learning model, okay? You don't want this, okay? You don't want your features to be proxies of each other. You want it to be independent. You want each one to be measuring something else. You don't want it to be measuring the same thing over again, okay? So that's what it means, okay? And those are the assumptions to use linear regression. Let's look at the pros and cons, okay? Well, linear regression is pretty easy, okay? Pretty easy to implement. It's not complicated, as we shall see. And it's used in business. Most businesses use linear regression to make predictions, right? They predict sales, they predict revenues, right? They predict prices. It is a lot using in businesses. And it requires little computational power. It's not very extensive, right? You can actually run this in your computer. If you have one of the latest laptop, can really do linear regression without any problems. And you can provide insights into the importance of your features, as we shall see later on in this presentation. However, the cons is that it assumes linear relationship. Okay, we're assuming that, remember, positive linear relationship, negative linear relationship. That was the first assumption or the first requirement. Well, it assumes that there is a linear relationship, but there may not be a linear relationship. There may not be at all. And it's sensitive to outliers, and it's sensitive to multicollinearity. Okay. And we talk about outliers, we're talking about values that are way outside the norm, right? Let's say that's the mean or the average. If you have values that are way outside the norm, okay, way, that'll be an outlier, right? That'll be an outlier. And it's sensitive to outliers, okay? And it's sensitive to multicollinearity, meaning that the features are correlated with each other. They are measuring the same thing, just like I said on the previous slide. So it's very sensitive to that. So you want to avoid that in your machine learning model. So those are the pros and cons. Applications, well, you can actually use in finance to predict stock prices, definitely. Yeah, why? Because stock prices, they're continuous, right? They're continuous variable, right? They're continuous. Of course, they affect in marketing because you can predict sales. Think about sales is, again, sales is continuous, right? It's a continuous variable. So in sales, you can predict sales based on marketing spending. That means that more, let's say marketing spending, right? X, Y. So this would be marketing spending, right? So we're assuming that the more you spend on marketing, the higher your sales, right? That's what we're expecting, right? So we can definitely create a linear regression model, right? To model that. Definitely, we can do that. And of course, it can be used in medicine as well. Patient recovery time. Mm-hmm. Because patient recovery time, remember, is continuous as well. It's a continuous variable. Remember, if your dependent variable or response variable, target variable is continuous, you can use linear regression, right? You can use linear regression. So that's the presentation about linear regression. Like I said, it's very simple. It's not complicated. Now, I want to cover the homework for this week because there have been some students who've been concerned about the homework because they feel like they are expected to know Python programming, but you don't need to know Python programming. I'm going to show you exactly what to do. Give me a second. Hold on. So let's look. Let's look. Mm-hmm. Okay, so this week I asked you, so I gave you a code, right? So I actually gave you a code. Let me open up that code for you. Let me open up the code. Hold on. Give me a second. Looking for the code. It's this one, I believe. Okay, so here's the code I gave you, right? So here's the code I gave you. And what I asked you to do was to duplicate the code in Google Colab. Last week, I showed you how to access Google Colab, right? And now I'm asking you to duplicate this code in Google Colab. And, and I realized that many of you do not know Python programming. So you probably wonder, so why, if you know that many of us do not know Python programming, why do you ask us to duplicate that code? It's because I want to show you the code. I want to show you the code that does the linear regression for you. You do not need to know Python programming to duplicate this code, okay? And I'm going to show you how to do this. Okay? But the main reason that I'm asking you to do this code, to learn this code, what it does, is because I want you to see what's going on behind the scenes, what computers are doing behind the curtain or behind the scenes, right? I want to show you what the linear regression code looks like, what the linear regression code does, and how it functions. I want you to see it. And I also want you to know that you don't need to create this code. You don't need to type this code, okay? You don't need to memorize this code. You know why? Because ChatGPT, large language model like ChatGPT, like Grok, like Gemini, like Claude, they can create this code for you. Okay, they can do it for you. So, like I said, the only reason I want you to know this code and be exposed to this code is because in the future, when you get a job, I don't know if you guys, I don't know if you want to be an AI consultant. I don't know if you want to work in AI, but if you want to work in AI, you need to be able to explain to your client what the AI is doing, okay? The AI will create a model for you, but you need to be able to explain to your client what the AI did for you. If you're going to explain to your client, then your client's going to be wondering, why do I need you when the AI can do it for me? And that would be a very valid question. However, if you know what the AI is doing, okay, you know what ChatGPT is doing, then you can explain to your client and your client will be very happy, okay? Or you can actually, if you're running your own business, you can create your own machine learning models using AI, and you will know exactly what AI is doing behind the scene. So that's the main purpose behind it. And I really believe that by the time you're done with this course, you should be able, to be honest, to create your own machine learning models. You should be able to do that because I'm going to teach you how to do this right now, okay? So here's the code. So I ask you, so duplicate this code in Google Colab. And here's how you do this. Okay, so here's the code, right? Here's the code. All you need to do is the following. Okay? Let me show you something. Give me a second. I have a lot of windows open. That's why I'm trying to see where am I. Okay, see it. See it. There. Okay, perfect. So we're back. So here's what I want you to do. Okay? And I'm assuming that everybody has access to a large language model. This large language model can be ChatGPT, it can be Claude, it can be Gemini, it can be Grok, okay? So this would be considered a large language model. So nowadays, large language models are able to do programming for us. They can actually create programs for us, okay? They can create programs for us. And they're becoming better and better every single day. I believe, I'm actually predicting within the next 2 years, we don't need programmers at all. We don't need developers at all, okay? And I know a lot of people who learn to program are very smart people, okay? It is difficult to do programming. It's not easy. It is time consuming. It requires a lot of intelligence. But unfortunately, AI can do a better job. It can do it faster, cheaply, less expensive, more accurate than a human can. Okay. So in the future, we will not need programmers. We don't need software developers because AI will do this for us. AI like ChatGPT, like Claude, like Grok, like Gemini. So they can do it for us. Okay. So I personally I use ChatGPT. That's what I use. Okay, to help me do everything. ChatGPT is it's like the most amazing technology ever created by human beings. It is the most sophisticated technology created by human beings because you are really talking. This AI is like talking, interacting with a human being who is highly intelligent, right? Because ChatGPT knows everything about that humans know. Pretty much anything that human know, ChatGPT knows. Okay, so I'm gonna ask ChatGPT to duplicate the code for me. Okay, so I'm gonna ask ChatGPT, do me a favor. I'm gonna give ChatGPT the code that I asked you to just download the code from the assignment. I'm gonna upload the code. Okay, so upload the code to ChatGPT. So here's what I will ask ChatGPT. Hello, buddy. By the way, I'm always nice to ChatGPT, by the way. Well, I'm always nice to it. So I say, hello, buddy, do me a favor. Please read the attached PDF, which has a linear regression Google Colab notebook code, Python code. Okay. Afterwards, please duplicate um, afterwards duplicate the code, the Python code, so I can uh, copy and paste into a new Google Colab notebook. Okay? So let's run it. Let's hit run. So it's actually reading the code. And there it is. Okay. So it actually read the PDF file that I asked it to read in the assignment. And guess what? It's duplicating the code. Okay. It's duplicating the code. And there it is. It duplicated the code. So let me ask this, buddy, are you sure that you duplicated the Python code, 100% accurately? Buddy, there is no errors. It seems like you failed to read correctly the PDF. So will it be better for me to take screenshots for you to read the code? Okay, so it is telling me that it would prefer screenshot of the code, okay? So I'm gonna take screenshot of the code, okay? So I can upload it. So I'm gonna go back to the code. So I'm gonna open up the PDF file that I gave you. And I'm gonna take screenshot of every single block of code, okay? So I'm gonna show you what I'm talking about. Where's the code? Here it is. So here's the code. So I'm gonna take screenshot. So I'm gonna take screenshot. You see, this is, let me see if I can write something here. Give me a second. So this, oh man, I made a mistake there. Give me a second. So here, let me see if I can write on it. I'm trying to write. Anyway, so this is actually, here is actually a block of code, okay? So there is a block of code from 1 to 16. So it goes from 1 to 16, that's a block of code. There's another block of code from 1 to 18, that's another block of code. From 1 to 14, that's a block of code. From 1 to 19, that's another block of code. And from 1 to 14, that's another block of code. So what I'm gonna be doing, I'm gonna be taking screenshot, okay? This block of code, and then I'm gonna upload it to ChatGPT, and ChatGPT will duplicate the code for me. For example, I'm gonna open this up. Give me a second. I'm gonna do something. Give me a second. I'm gonna share my computer screen, not the entire screen. I just wanna show portion of the screen. So here, so you can see what I'm doing actually. So I'm gonna take a screenshot of this block of code, okay? I took a screenshot of that block of code. So I'm gonna copy that into ChatGPT. And I'm gonna ask it to duplicate it. It's analyzing the screenshot, and there it is. So it's gonna duplicate that screenshot, the content of the screenshot 100% accurately, and there it is. It's duplicating it 100%. And let's do the next block of code. Let's take a screenshot of the next block of code. I'm gonna take this code, and then I'm gonna feed it to ChatGPT for me. And I'm gonna ask it to do the same. It's doing the duplication. Okay, perfect. Or you can do the following, okay? So I'm gonna show you something. So that's one way of doing it, right? You can take screenshot and ChatGPT can do it for you. Or you can do the following for me, okay? Remember that AI can do the code for you, okay? So I'm gonna give it what I'm gonna do, I'm gonna give it my data set, the data set that you have in the assignment. So I'm gonna upload the data set instead. So I'm gonna create a new, so I'm gonna load my data set. The data set is housing, I'm gonna upload it. And I'm gonna ask ChatGPT, buddy, please read the attached CSV file. Afterwards, please create a Python code for Google Colab notebook that will input, okay, that will input the data set, clean the data set if necessary, and conduct statistical analysis, conduct statistical analysis, okay, of statistical analysis to make sure that the assumptions of linear regression have been met. Then create the model, create the model, the linear regression model, and give me prompts to make predictions. And let's see. So you read the data set that I uploaded is thinking about this, is thinking about it. Is writing the code. Here it is. And it's right, there it is. It is actually creating the code for the machine learning algorithm. See that? It's doing it for you. So what? So let me. While it is doing that, let me tell you something, okay, about privacy. Now, if you upload anything you upload to ChatGPT, to Grok, to Claude, to Gemini, they have they can actually use it to train future models. So if you have any concern about privacy, do not upload a data set that might have sensitive data, okay? You don't want to do that, okay? Because companies like OpenAI will take whatever you upload and they will use it for training purposes. There's an option under ChatGPT where you can actually tell them that you do not want your data to be used for training purposes, okay? There's an option. You can do that, and you can choose not to allow them to use your data set for training purposes. However, you should be very careful because some data, as you already know, some of you are lawyers, and you know that some data are protected by law. For example, HIPAA. Medical data is protected by HIPAA, by medical law. So you may not want to upload data set, right, that are protected by law. However, there is a way to go around that, actually. For example, let's look at this data set. There's a house. This is the housing data set, right? This is the housing data set. So let me make this smaller. So this is the housing data set. So if I'm worried about privacy, here's what I will do. Okay, so I will take my data, and what I will do, I will delete all the data, okay, all the actual observation. That's what I will do, right? I will delete all the observation. Okay? I'll delete all the observation, and I will leave, okay, I will leave the features. I will leave the features, and I will leave the dependent variable. And then I will save it. Then I will kill a file, save it. Then I will feed it to ChatGPT and say, ChatGPT, can you please create a code, okay, a code that will perform a linear regression, and the dependent variable is price, and the other variables are the features. And then ChatGPT will give me that code. And guess what? I can run this code locally on my computer, okay? Don't use Google Colab, but instead use a Python IDE in your local computer that is not connected to the internet. And then you upload into that code, okay, the actual data set, the data set that has all the values. So then you will load the actual data set that has all the observations. But you will only do this locally in your computer, your personal computer. You will not do it on the internet. And you will not give the observations to ChatGPT or any other large language model. You will run the model locally on your computer, okay? That's what I will do, okay, in order to protect the data, the privacy of my data. So those are the ways that you can actually duplicate the model using AI. And this is the reason why I wanted you to duplicate this code using AI, because I'm literally, a lot of people do not realize that AI can do this for you. People don't understand that AI can actually do the coding for you, and you can run sophisticated machine learning algorithm models, okay, on your computer with the assistance of AI. Think about that. This is a very powerful tool that you can use to run sophisticated machine learning models on your computer, okay, with the assistance of AI. So that's how you can actually use Python. You can actually use ChatGPT. Again, you can use ChatGPT, Claude, Grok, Claude. You can use any of those. I know that Gemini is actually one of the most highly sophisticated AI out there right now. It's actually better than ChatGPT. And they can all actually do this. What I just show you, they all can do it, okay? So as you can see, you can actually create highly sophisticated machine learning models using AI as your assistant, okay? It will assist you in creating these machine learning models. And that's the reason why I create this assignment, so I can show you what is possible, what you can do right now. You don't need to wait until this class is over to start creating highly sophisticated machine learning model. You don't need to wait. You can do it right now with the assistance of ChatGPT or any other large language model out there, okay? And in the future, these large language models like ChatGPT, they're gonna become more sophisticated. They're gonna be able to actually create software and deploy software in the App Store for you, okay? They're gonna do amazing things. Let me give you an example. So I'm gonna ask ChatGPT to do a program. Okay, so this is something different. This is not related to machine learning. So I'm gonna ask him, hello, buddy, please create a Python program that, I don't know, that will calculate, I don't know, to calculate the, actually, that will take, that will input the names of my clients and their information, such as address, phone number, what else? Address, phone numbers, email, and emails. Okay. And store them as a database in Google Colab. And there it is. It just created a program, just like I asked you to do, that will input, okay, client's information, and it will store it in a database. See that? So I hope everybody understands how useful AI is and how you can actually use it right now. Okay. And like I said, you don't need to wait until this class is over to start creating sophisticated machine learning models. Just keep in mind about the data privacy. That's a major concern. Okay. So keeping that in mind, you don't want to be inputting data that is private. So, and if you want to do that, if you want to do a machine learning model for data that is private, I think I gave you a workaround about that to keep it safe. You can do the machine learning model locally on your computer and make sure it is not connected to the internet. That way the data is not compromised. So now, so that's how you do it, okay? So now what I will do, I'm gonna explain that code for you. So let me explain that code for you. So give me a second. Okay. So here's the code. Okay, so you're gonna find something interesting about this code. They all look alike. All of them, they look very similar. Okay, they all do the same thing. You're gonna learn as we go through these codes, all the different codes. For example, logistic regression, decision trees. We're gonna see that all of these codes pretty much are arranged in the same manner. Okay, so the first block of code, they always do the same thing. We import the libraries that we are going to be using to create a machine learning model. Okay, so it's always, that's the first thing they always do, okay? We import the libraries. That's the first thing we do. Then we import the data set. In this case, we're gonna be importing housing CSV data set. Once we imported that data set, then we wanna look at the features of the data set. So we actually tell, hey, can you show us the first 5 rows of the data set? And it shows the first 5 rows. So 1, 2, 3, 4, 5 rows. And as you can see, we got area, bedrooms, bathrooms, stories, parking, and price. So we can see the data set here. And then the next line of code, it does statistical summary, okay? So we see, for example, the count, how many observations we have, the mean, the standard deviation, the minimum, the maximum. And you're probably wondering, why do we need to know this statistical summary? Well, you're looking for outliers. Remember that one of the deficiencies, one of the weaknesses of linear regression is outliers. We want to identify, are there outliers in this data set? And if we find them, we want to delete them. For example, let's say, look at bedrooms, okay? Let's look at bedrooms. The minimum is 1 bedroom, right? And the maximum is 6 bedrooms. What if, this is just an hypothetical. What if instead of having a max of 6, we have a max of 200? What would you think? If you actually saw 200 here instead of 6, what would you think? You'll think that something is not right. There's an outlier because a house cannot have 200 bedrooms. It's impossible, okay? It's impossible for one house to have 200 bedrooms. So you'll know immediately that there's an outlier in the data and that outlier needs to be deleted. The same, here's an example bathroom, right? So the minimum is one bathroom. The maximum is 4 bathrooms. What about if you have like 1,000 bathrooms? Then you know something's wrong with the data. Something's up. There's an outlier that is going to mess up your model. And you don't want that, right? So you want to see, because a lot of times when people are collecting data, they make mistakes and they create outliers. Okay, so that's what you're looking for, okay? Then we move on to the next one. You want to create graphs. Remember, there's supposed to be a linear relationship between the features and the dependent variable. There's supposed to be a linear relationship. Well, we graph it. We graph the, here's the price. We graph the price, which is dependent variable, and the features with each feature to see there's an actual linear relationship. And as you can see here, I wonder if I can write, give me a second. I wonder if I can do this. Hold on. I want to show you. So there is a linear relationship. See that? There's a linear relationship. There's definitely a linear relationship here between price and area, definitely. Now, bathrooms, stories, and parking, they're ordinal, ordinal categorical variable. Okay, they're ordinal. Okay, so since they're ordinal categorical variable, here's what we're looking for. Okay, we look at that as the number of bedroom increases. We want to see that the house prices are higher. Okay, that's what we see. So here's a 2-bedroom. So we see the house prices are here. This is a 3-bedroom. We see the house prices are here. They're actually higher. 4-bedroom, we see that a little bit more higher. Okay. 1-bedroom, they like lower in price. So we see there is we said that their blocks of prices are keep going up as the number of bedroom increases, right? So that's actually good. This is good. And the same for all the others. We want to see that the groups, okay, keep going up. Okay, so this one is not 100%, but it's a little bit. Okay, so that's what we're looking for. So let's continue. Oh, let me erase this. Okay, give me a second. Eraser. I never actually used this before. Eraser. Can I erase this? Erase it, erase it. Perfect. So let's continue. Now, in this one, what we're trying to see if the features, okay, if they are, we're trying to graph it to see if there's any, again, we're trying to see if there are any outliers, okay? We're trying to find outliers. So we're trying to find the distribution of your features so we can see if there are any outliers, because we do not want outliers, because outliers will mess up your model. So look, for example, look at bedrooms, okay? So we have 1 bedroom, 6 bedrooms, okay? So that means that this is pretty good because we know that the data is between 1 and 6, okay? What about instead of having 6, we had like 200? Then we'll know, wait a minute, something's not right. How can there be 200? There's something wrong here with that data set. So the point of this graph, which we're actually distribution of your data, is that we're looking for outliers. Oh, we don't want outliers. We want to delete those. They're going to cause problem for you. Then we move to correlation heat map. It's a correlation heat map. And remember, you can use correlation heat map to see if your features really impact your dependent variable, okay? Remember, you want your features to have an impact on your dependent variable. So use a correlation heat map to find that out, okay? For example, here's the dependent variable, right? Price, okay? So we find a correlation analysis with each, okay, with each feature, okay? With each feature, okay? And we're trying to see if it's like maybe 50 or more, okay? 50 or more. So you can see that there is a moderate relationship here between price and area. There's a moderate relationship between price and bathrooms. Okay, so there's a kind of weak relationship here. There's a kind of okay relationship. So here is telling you which are the features that had the highest impact on price, okay? And the 2 features that had the highest impact are area and bathrooms, right? Then it goes to stories, then it goes to bedrooms, and then it goes to parking. So it tells you the influence that these features have on price, okay? That's what it shows you, okay? Let me erase that for you. Let me erase that. Let me erase it. And now the thing that we're trying to avoid, we don't want the features, okay, we want it to be independent. Remember that we want the features to be independent. We don't want it to be proxies. Remember, I mentioned that we do not want them to be proxies. We don't want proxies, okay? So what you do, okay, so you actually look at the correlation between features, okay? because we don't want it to be proxy of each other. Because if they are proxy of each other, we do not want that at all. Okay? We don't want that at all. So let's continue. And then here, what we do, this one assigns the features, okay, to X and assigns the dependent variable to Y. And then we create two data sets. Remember, we have one data set, but we need two data sets. We want that one data set for training. Okay, we want one data set for training, and we want the other data set for evaluation, okay, to evaluate the model. So we want two data sets. So we're going to take the original data set, okay, original data set, okay, we're going to split it into training and evaluation. And that's what we're doing here. We are splitting the original data set into training and evaluations. And we continue. And then we scale it. Okay, we're going to do some scalar. Okay? We're going to scale it. Why do we scale the data? Well, here's the reason why. Let me show you something. Why do we scale the data? Look at this data set here. Okay, let's go back to the data set. You notice that the area has very high values, 7,400, 8,900, 9,900, 7,500, 74. You notice that has high values. You notice the bedroom is only 4, 3, 4. Bathroom is 2, 4, 2, 1. And the other one, store is 3, 4, 2. And parking is 2, 3, 2, 3. Very low values, right? If we were to just leave it like that, okay? If we just leave it like that data set like that without scaling it, okay? Without a new scale, then the area will have a higher influence on the model. And that's not good. We want all features, okay? We want all features, we want all the features to have equal influence, okay? That's what we want. We don't want one feature to have all this power over the model, okay? We want all features to be in, so we scale it, okay? We rescale probably from 1 to 0, from 0 to 1, okay? We rescale it, but we maintain the same scale, but we lower the scale. So that's what we do, scaling. So let's go back to where we were. Let me see, scaling. So we're here, we did that. Now we train the model, we get the model trained. Okay, so here is the model being trained, linear regression. Once the model has been trained, then we evaluate the model to see it's a good model, bad model. What kind of model is it? Well, here's the R-square, okay? So this R-square is 0.54, which means that 54%, okay, of the variation in the dependent variable, which is the price, right? That's a dependent variable. 54% of the variation of the dependent variable can be explained based on the features that we selected, right? We selected those features, and those features can explain 54% of the variation of price. That's what it means, okay? And that's pretty good, to be honest. That's not that bad. Of course, you want it to be maybe 80%. Okay, maybe that's what you want, 0.8. 54 is not that bad. It's not that bad. We delete that. Let's continue. Here, we actually are mapping the actual values versus the predicted value. So here the actual price. Here's the predicted price. This line is the perfect prediction, right? The actual values and the predicted values match 100%, okay? 100%. That's 100%. So any observation that falls in this line is perfect match between actual values and predicted values, okay? Actual match, perfect. So we're trying, so let's see. So as you can see, some values are higher than the actual value, and some values are lower than the actual value, okay? And I want you to notice something interesting. The lower price houses are normally, the prediction are actually higher than the actual value. Okay, so these low price houses, the model usually predicts their prices to be higher than the actual value. And these high price houses, the model usually predicts the value to be lower than the actual value for high value price houses, right? And of course, we don't want this. We want the prediction to be the same, no matter if it's low price houses or high price houses. We want it to be the same, right? So let's continue. And here's the residual. Now, these residuals, okay, that's the difference between the residual, is the difference between actual values and predicted values. So residuals is pretty much actual values, right? Minus predicted value, predicted. You get residual, right? Residuals, okay? Residuals. So it is the difference between actual values and predicted values, okay? That's what it means. So we want these values, okay, to be the same across lower values and larger values. And we want this to be all over, to be random. We want all this to be random. We don't want any patterns. We want it to be random, okay? Just like I showed during the presentation. We want it to be random. That's what we're looking for. And this is kind of random, to be honest. Kind of. Let me delete this. Delete this. Okay. And this one does show that it to be normally distributed, so it's actually pretty good. It's not that bad. It's pretty good, to be honest. It's pretty good. And that's the end of the code. Okay. And I just show you the code that is used to create linear regression, okay? This is the code. And that's the reason why I ask you to duplicate it and to learn from it, okay? So I want you to see what's going on. I want you to see it. Probably most of you have never seen this before, most likely. Most of you have never seen a linear regression code ever in your life. And this probably is the first time you see a linear regression code. And I just show you in about 30 minutes how it works, how it functions, right? How it works. And I show you how to create it. And I show you how you can upload a data set and it will do it for you. The AI will do it for you, okay? So again, having AI do it for you, what I just show you, okay? It can be ChatGPT, it can be Grok, Gemini, it can be Claude. These large language models will do it for you. It will be very easy for them to do it for you, okay? And that's the end of the presentation. I wish, if you have any questions or concerns, please let me know. Have a wonderful day. Take care, everybody.